There are two parts for the question. First one, how the electric field inside a parallel plate capacitor change when a dielectric slab is filled completely the space between the plates. Second part, a slab of dielectric constant has the same length and breadth, means area as the plates, but the thickness is half of the distance between the plates. We need to find an expression for the capacitance when the slab is placed between the plates. For a capacitor with air between the plates, there are two plates for the capacitor. Each plate can be considered as a thin sheet. Electric field intensity due to a thin sheet is sigma by 2 epsilon 0. There's a negative plate also. The electric field of the plus and the minus are in the same direction between the plates. So they get added up, will give you 2 times sigma by 2 epsilon 0 because it's air. So 2 get cancelled with just sigma by epsilon 0. Single plate was sigma by 2 epsilon 0. The plus plate and minus plate both get added up between the space of the capacitor plates. So sigma by epsilon 0. Now when this is filled with a medium, whenever mathematically when you discuss, wherever there's a medium comes, the epsilon 0 will be multiplied with the epsilon r, or it is same as another name, dielectric constant K. So electric field with the dielectric will be sigma by epsilon 0, denominator again K. So sigma by epsilon 0 is E air. So if we can replace sigma by epsilon 0 as E air, so E dielectric will be E air by K. And K value is 1 for vacuum. The rest all media K is greater than 1. Since K is greater than 1, when you divide a quantity by 1, it will be same. Greater than 1, the result will be less compared to the quantity getting divided. So E electric, E with dielectric become less compared to E with A. So this is the mathematical explanation. Here this is the field, dielectric becomes K, but K is greater than 1. So the result when you divide with greater than 1 becomes less than the existing value. Now, in terms of polarization, when you keep a dielectric, the molecules of the dielectric get polarized. It produces an electric field opposite to the applied electric field. The induced electric field strength will be always less than the applied electric field, as the material is an insulator, dielectric. So the net electric field will be reduced because of the induced electric field produced in the opposite direction. For more clarity, we can check the dielectrics, or the effect of dielectric placed in external electric field. This is for the first part. For the second part, we have an expression for capacitance with partially filled dielectric, A epsilon 0 by D minus T plus D by K, where D is the distance between the plates of the capacitor, T is the thickness of the dielectric slab, and K is the dielectric constant. So as per the question, the thickness of the dielectric slab is given as equal to half of the distance. So just substitute T as D by 2 in both the places. So D minus D by 2 plus D by 2K. D minus D by 2 will be D by 2. You can take D by 2 common. So D by 2 come common out, 1 plus 1 by K. So now take LCM, K plus 1 by K. So the K will go on the top. So 2 K epsilon 0 K Yeah, the d by 2, d also go on the top. So 2a epsilon 0 k by d into k plus 1. That's a final capacitance when it's half filled with dielectric. That's a B part. This is the A part.